So, hey everybody, welcome back to a new video. So, a lot of you had asked for Bjartek to actually explain the metadata standard on this YouTube channel, and so lo and behold, we have the legendary Bjartek with us to explain the new metadata standard, which we're really excited about. And so, Bjartek, do you mind introducing yourself a little bit?
Yeah, hello. My name is Bjartek, or Bjartek, as I go by in the Flow ecosystem. Uh, I participated in Open World Builders in 2020. I can't say last year even now because we're in
Yeah,
2022.
yeah,
And where we did the Versus project, so that's Versus.auction. And then the last year, actually in December, I quit my day job and started building up Find. And
awesome.
while I'm doing that, I've also been working a lot with the metadata standard to get that landed, and we're really getting close now. So doing this video now, I think will be very beneficial for you guys to get a little sneak peek on what's going on here.
Yeah. So thank you so much, Bjartek. I'm sure a lot of you who are watching this video have seen him before in the many discords. He's a huge part of the Flow community, and so we're very grateful to have him here. So what we're going to be doing today is sort of walking through how you would get metadata from an NFT in the old ways. And so what that is we're going to walk through an example contract and show you how that's currently done. And then after we do that, we're going to show the new metadata standard and how you would get the NFT metadata using that new standard. And so this sort of assumes you have some sort of base level understanding of how Cadence works. And if you don't, then we have other videos on the channel to watch as well. So let's get started. And I'd also like to mention that while we sort of walk through these examples, it's very reasonable that we might run into some errors, but that's sort of the point of this video, is to work through those errors together and see how we can implement the standard. Okay, awesome. So what we're looking at right now is the old example NFT contract. So actually, if you go to the Flow GitHub and go to Flow NFT, you can actually see this is the current example implementation of the NFT contract. And so I've just simply copy and pasted that into the Flow playground here. And you can see that, our NFT right now has some base metadata here, right? It has a name, it has a thumbnail, it has a description. And so we're going to walk through how to set up the account and mint an NFT and then view that NFT metadata so far. So does that sound good, Bjartek?
Yeah, perfect.
Awesome. So yeah, and one other thing. Okay, yeah. So let's just do that first, and then we'll sort of get into some detail. So let's first set up an account by giving the account a collection. The really main important thing to see here, if you've worked with NFTs before, is that when we link the NFT to the public, we're using example example NFT collection public. And the reason for that is because inside of our contract, if we go to our contract here, you'll see that we're doing that because we want to be able to call the borrow example NFT function that will return a reference to our NFT and allow us to then read the metadata. So that's what we're really going to be doing right now. So let's go ahead and just set up a random account. So let's set up account 2 and let's clear our console here and set up the account. And so it says set up account. So boom, account 2 has a collection in its storage. And so then let's go ahead and mint an example NFT. The recipient's going to be account 2. The name, let's just name it Bjartek. The description is going to be a cool person. And the thumbnail is just going to be just like dummy info, right? So we don't know what we want to put there yet. So we're going to sign this by account 1 because account 1 is the one that has the minter in the contract.
Three.
Oh, well, it should be account 1 because that's the one that we're working.
Okay, yeah, sure. Yeah.
So account 1, perfect. And so if we actually mint this NFT, it'll say, oh, so I guess maybe not.
It is 3.
Oh, it is 3. Okay, yeah. So let's actually sign up from 3. Oh, you're right. Yeah, you're totally right. So let's sign up from 3 and minted an NFT. Okay, awesome. So we just went ahead and minted an NFT. Boom. And now let's go ahead and view that metadata. So this is using the old system. So if we are at the old system now, we see that I just hard-coded the address here for whose account we're gonna be reading, and the ID, right? So this account just got minted in an NFT. It should have ID 0 or maybe 1 because we may have done some setup before the video. But anyway, that's not that important. What's important here is that it says example NFT. What we're borrowing from account 4 storage is the example NFT collection public. And so what we're going to do is we're going to borrow the example NFT, which just returns a reference to the NFT. And then we're going to manually read the metadata here. So you'll see there's no standard around this. It's very loose, but that isn't necessarily a good thing. And so Bjartek, I don't know if you want to jump in here and mention maybe some downsides to this while we're doing it.
Yeah, so while we're building Fine, we have a collection script in Fine to like fetch all collections. And there you really notice the pain points of this not being a standard, because we have to hard code things and figure out and reverse engineer code just to show a simple NFT in our collection, right?
Mhm.
It's hundreds of lines of cadence and like 10 lines of cadence for each different data source, since there's no standard.
Yep, exactly.
And that's really what we want to do here. We want to create a standard where you can discover and browse and find out things, not hard code and know things up
Yep,
front.
yep, exactly. So we just minted an NFT to account 2, so let's go ahead and read their metadata. Now this may fail because I'm pretty sure it might be ID 1 or something. Yeah, so I think it actually is ID 1 because we did some setup before the video. So let me go ahead and try that one. Yeah, so here we go.
Yeah.
So here's the NFT now, and it's very wonky on the playground, but you can sort of see here that if we look through the fields, what we're returning is a NFT result struct that we defined down below. And so it has a name, a description, a thumbnail, an owner, and a type. And we got all those fields just by setting, we had a base struct here, and we just set the fields inside of it by the NFT reference that we got. And so you can see the one of the string values is Bjartek. That's what we minted. A cool person, and then it says, dummy info for the thumbnail, the address, and all that, right? So this is what we did in the old example. Just to reiterate, is we borrow example NFT, and then we just read them manually, right? And so in this next part of the video, we're going to sort of go over the metadata standard. So Bjartek, I know you sort of mentioned it already by the last question, but did you want to give more like a very maybe conceptual understanding of what the metadata standard is? And we can actually do that by hovering over the
Yeah. So the main ID of the metadata resolver is the resource interface that is on line 21 to 24 here. So the thing that we're doing with the metadata standard is this contract will be deployed on the same account as a non-fungible token on both testnet and mainnet. And the PR for that is being worked on right now. And it's getting really close to have the two resource interfaces on top here merged. The structs that are further down, they have been taken out from the main PR because we want to discuss those later. The first thing we want to do is to discuss the interfaces. So
Yep.
another thing that's we're not gonna show that now, but it will come in that follow-up video, and that is in the future there will be the resolver interface will be default implemented by the non-fungible token. It requires a feature upgrade to the Cadence language that is slated to be merged soon. And then you will be able to remove even more code than we have done now and get an even slimmer implementation. But what we're basically saying here is that our NFT have two methods. One of the methods is called getViews, and that returns an array of types. And that basically tells to the user what types can you be viewed as. So you can view what type can you be viewed as. So one of the types here is the display struct on line 36, right? So you can be viewed as this type. But the sky is the limit here, really. You could, if you have a solution you're making that kind of needs rarity, you can define a struct that enables NFTs to describe rarity in the format that you want it, and say everybody that implements my struct I can deal with, I can work with, right?
Yep.
So, but it's really important to agree on a standard set of structs early on. So that's the next step in the NFT discussion. So if you are interested in that, I would recommend you strongly to contact Pete in the Flow Discord, or me, or Jacob even, and we can get you involved in that discussion so that your views and your solutions demands are met.
Yep. Awesome. Yeah. Thank you for that explanation. So I just want to like reiterate what Bjartek said, because this is it's so cool what they've done with this contract. And also I want to sort of emphasize the why this is so cool in Cadence. It's because you'll notice that get views returns an array of types. Now that's very generic, right? A type is a very generic thing in Cadence, and resolve view also takes in a generic type and returns a very generic any struct. So there's a lot of flexibility here through Cadence. And just like Bjartek said, this display struct we're going to be using as an example, and sure, it's deployed in this contract. So if your get views returns display here, you could pass in the display type and get back a display. But like Bjartek said, you can define your own contracts with all of your own structs. It could be named whatever you want, and you could use that as a resolver.
Yeah, I also have some code on converters between different views if you want to migrate them. So let's say you have version 1, but you want version 2 out. I have some code that can convert things from. So if you can be resolved as version 1, then you can also be resolved as version 2, sort of. So it's very generic, but also the semantics here are a bit important on method on the line 23 here. So if you call things with a type that you don't support, you should return nil. You should not panic, right?
Yep.
So you have to expect you should never call resolve view with a type that you don't get from get views. But if you happen to do it, you should never panic. You should always return nil. Right? That's Dieter really wanted that, so that's why that semantic is there. The initial suggestion was to panic, but he felt that was a little bit harsh, and I kind of agree with him as well.
Yep. Exactly.
So the another resource interface is here. That's the collection resource interface. So the resolver collection. So these are two new methods that will be added to collections of resources. So it's not only NFTs. So let's say you have the NFT storefront has a market collection. That could implement resolver collection so that you can use the metadata standard for viewing listings. You could do this if you have other collections of resources. For instance, in Find, a name is not an NFT because the name is the identifier. It's not an integer that's the identifier. And there are some semantics of NFTs that doesn't fit in Find. So, but that could also then implement a resolver collection so that you don't care about the implementation, you care about the behavior. That's the essence of the new standard.
Yep. Awesome. Yeah. So what we're gonna do now is we're gonna actually show you. First of all, we're gonna take the example NFT that we just worked with, and we're gonna we already copy and pasted over to account 1, and we're gonna change it to work with the metadata standard, which is exactly what a lot of you wanted to see. And we're gonna do that using what we're gonna do is we're gonna use these things here. We're gonna make the NFT implement resolver. We're gonna make the NFT collection implement resolver collection, and then we're gonna read the metadata through this display view, which is super cool. So let's go ahead to account 1 and let's start configuring it to work with this metadata standard. So the first thing we want to do obviously is to import metadata views from account 2, right? So that's where it's deployed. And then let's go ahead and the first thing we want to do, right, at Bjartek, is to make sure the NFT implements the view resolver.
Yeah. So this is something you need to do now, but later you don't have to. Or that will be defaultly implemented for you in the future. It's a resolver.
Yeah. So you can keep going on that. That's really important.
Yeah. So in the future, the NFT resource needs to have that, because that will be in the it will be in the NFT standard will demand that you have a metadata view resolver, but it will be defaultly implemented for you to just return no values.
Yep. Exactly.
So when Cadence is updated and the NFT standard defaultly implements the metadata view resolver, no code will break, right? All code will just work, but until you upgrade your contract, it won't support any views. It will just return no views are supported and always nil for resolve, right?
Yep. Exactly. And so what that means is like, so right now, you know, our NFT is implementing the resolver resource interface. So like we've learned in previous videos, you know, that means we have to implement these two functions here. So let's go ahead and copy these over. And what, you know, just to reiterate what Bjartek was saying, this means that, you know, right now, all the, you know, all your NFT implementations that are out there right now won't have this, right? Because they're already deployed, but they will have default implementations, which means that in reality, this will just be like an empty function, right? That just like, let's say returns behind the scenes, it's just returning
exactly
an empty array.
Yep.
And same
Return
thing here,
nil.
this will just like return nil, but but you won't even see it. It'll be there behind the scenes, which is a new feature in Cadence and will be super cool.
Yeah, you could that feature, and so there are a couple of features that's coming to Cadence soon, and all of them will change how you code Cadence. You will write a lot less code and a lot more generic code in the future, and I think it will be a far better world than what we have now.
Me too. Yeah, exactly. And so, of course, for our example, we're going to actually, you know, we don't have default implementations. We're actually going to implement them ourselves because we want to support the display type for this NFT. So, it'd be helpful. I guess we could take a peek at what we have over here, but I haven't done this too much. So, Bjartek, if you'd like to, it'd be awesome to have you walk us through how to implement these ones.
Yeah, so here you have to get a type, right? So you just return an array, and in there you write type.
Yep.
And then a parent, and then the no, sorry, it's not that. It's like that. Yeah, less than.
Oh yeah.
And
just like this.
Yeah, metadata views. So it's the name of the class.
Yep.
Or the field, and then it's display. Yeah. And then you end that, and no, you have to end it. No, it's.
Oh, well, you end it first, and then you do the parentheses.
Yeah, write that.
There we go.
So this, but if you have a display type already, you can just use get type on that, right? If you have an implementation of that already.
Exactly. Yep. So just like Bjartek said, we're getting this display from the metadata views contract. But you know, if you have your own, let's say you have your own, you know, views in the separate contract, you would just replace this with whatever, or you know, not replace it, but you could even add it here if you want to support both, right? So if you want to support multiple, you would just do type, and then you know you would do your next thing right
string.
Here.
Let's say string. That's a cool one.
Yeah. So let's just do type, which is string.
Yep. And yeah, like that. So now you support string and that one.
So there we go.
For the resolve view, I think you can just copy the method because it's a little bit.
Yeah, exactly. So now we'll remove this in a second, but let's just keep it there for now because it's cool. So if we go back, the next one we're going to implement is resolve view. So let's go ahead and copy this one over, just because it's going to be easier to explain it this way. Okay.
Yeah. So here you basically switch and say that if the type is metadata views, then you just implement that basically. So if you want to implement string here, it's really easy. You just
we can even go ahead and do that, right?
Yeah, you could. It's really, really easy. You just write string, like that, colon, and return self.name, right?
Oh yeah, there we go.
Self.name, right? Now you've implemented the stringer.
There we go.
The stringer pattern from Go, or the toString in Java, or whatever you call it, right?
Yeah. Exactly. And so, you know, like Bjartek was explaining before, this is a way of viewing this NFT. That's why it's called views. So when we say that we support the display struct here or string, that means this NFT supports being viewed as these two things. And so that's why down here, if we were to pass in the metadata views.display as this type here, it would give us this return value, which is the, you know, the display struct with the name, the description, and the thumbnail, which are all defined right here.
Yeah. So now the core NFT is done. We don't have to do anything more, but you have to do something in the collection.
Yeah.
Because the collection needs to implement the new metadata views resolver collection interface.
Yep. So this is going to have to support the metadata views.resolver collection. And we can even go ahead and look at this again inside the metadata views contract. So what that is these two things right here. So we could even go ahead and copy these over because we know we're going to have to implement these.
You don't need to copy get ID because you have get ID.
Oh yeah, you're right. Yeah. So if we go back, let's go into our collection, copy them here, and we already have get IDs, right? So we don't need that. But here we are. So we need to support this function now. And so public function borrow view resolver. So I guess we could copy and paste this over if we wanted to, if it's easier.
Yeah, it's very similar to borrow example NFT. But
Okay,
if
yeah.
you just go over there and view the way it is,
Yeah.
this will also probably be defaultly implemented, right?
Mm-hmm.
Later on, so you don't have to write this yourself either.
Yep.
Eventually.
Yeah.
Yeah.
So what this is doing is, I guess you could walk us through it if you wanted to, Bjartek.
It's just basically cadence. You have to jungle the types in cadence, juggle them correctly. So you borrow it as auth reference, and an auth reference can be casted as something that is more specific, as you're doing there. And then after you've done that, you cast it as the correct specification, the correct classifier, I guess you call that. Or what do you call those?
I think it's just like a resource interface, but like, I mean, specification. Or like
an interface. An interface is the best way. So the interface.
Yeah, exactly. And so so like Bjartek said, this is just juggling the types like we do in the example NFT, and then this one, restricts it to the metadata views.resolver, so we can actually view some stuff on it. Now, for those of you that are have been watching a lot of my videos, this is the same thing as just doing this. Any resource is just sort of like an added word there, but you don't have to put that if you don't want. It's the same exact thing.
But it's really important here to not use the concrete type on line 128. You have to be any resource here.
Oh,
I'm not sure if you've covered it like that in other videos, but in general, a lot of people recommend using the specific type there in addition to the interface. But in this case, we can't. We have to use any resource because it has to be generic, right?
Oh, really? So this is different from this in this case?
No. But what I'm saying is that many people would advocate writing example NFT there, not.
Oh, you're right. Yeah.
Not.
Yep.
Because that's more secure. Because then somebody else can't come and implement your interface and try to act as you.
Yeah, you're right.
Small security hole. It's not very likely, but it's there.
Yeah. So you want to make sure you don't put like example NFT here, right?
Yeah,
so it has to be generic, which is either this one or this one.
But as I said, this one will be differently implemented. So you probably will, after March or whatever, you probably will never write this, right? It will always just be there.
Yeah. And so now that we allow ourselves to sort of read this NFT, right? Because we're returning a reference to an NFT that will allow us to call the .get views on it. So we actually don't really need this function anymore, right, Bjartek?
Yeah, that's dead now. You don't need that anymore. And there's a lot more you don't need anymore, because you don't need that you don't need that one either. You could have it here. So if you have if you need the borrow example NFT because you have a function somebody wants to call on your NFT, a public function, then you can have it there. But that's not very common to have public function on NFTs. Private functions or auth functions that you borrow to get, those are fine. But in general, you don't need that. So then you can just remove that code and it just goes away. Exactly,
right? Because usually you would want to ask yourself, like, why do I need a reference to the NFT? Well, in this case, it's because we wanted to read its metadata. So if there were functions on it, like Bjartek said, you would just you would still have this. But because it's just used to read the metadata, and we have another way of doing that, we don't even need this entire resource interface now, and we can simply get rid of this requirement as well.
Yep.
All right. So this is just going to give us an error, but we don't need this anymore. So this is just it's just going to give us an error, but we'll show why we don't need that in a minute here. All right. So now our collection supports borrowing a view resolver, so we can go ahead and deploy this contract, I think, right?
Yeah.
So of course the playground is going to be super buggy, so let's just sort of ignore the man behind the curtain here while we redeploy all the contracts, because the playground is still in its I guess beginning phases. But if we go ahead and redeploy everything, it should deploy just fine. So here we are. All right.
Yep. Awesome.
So let's go ahead and set up our account so newly. And so look, now it's going to give us an error here, right? And why is it giving us an error? Well, remember, we just removed example NFT collection public, but we added a new way for us to be able to view our collection and resolve the views. And so what should we put here instead?
Metadata views dot resolver collection. The
Right.
generic.
Resolver collection. Yep.
Yeah.
And so once we do that, that will allow the public, right? Because we're linking this to the public path to go to our collection and view our collection with certain views. So we can go ahead and set this up. So let's set up account 2, I guess, just for fun. So we set up an account, and now we can go ahead and mint an NFT into that account. So the recipient is going to be 2. The name is going to be, we'll do Bjartek again, just to keep things similar. A cool person. And then we will do a thumbnail, which will be like dummy thumbnail. Okay. Boom.
Yep.
And then we have to make sure we're signing from account 1, because that's the one that has the minter, right? That's just also kind of behind the scenes. Yep. So if we mint the NFT, oh, so this should be from 1 now. Yeah, so this should be from 1 now, sorry. Yep. So if we go ahead and do that and we send the transaction, then it says minted an NFT, boom.
Yep.
And let's go ahead and view the metadata. So this is where things get really cool and also interesting, right? So
yeah.
So I guess Bjartek, would you like to sort of walk us through why we're borrowing this instead of the example, borrow example NFT now?
You don't have the interface, the specific interface anymore. You don't have that anymore. Now you only have the generic interface, right?
Yep.
So you're just using the generic interface, and then you just borrow the view resolver on line 15 instead of borrowing your concrete implementation. You just borrow the generic one, and then to get the data, the name, the description, and the thumbnail, you just resolve the view, and you just have to cast that view as the type. So it's a little bit clunky. If we had generics in Cadence, we could solve line 21 to say that resolve view had to return a display type, right, or an optional T, as you would call it. But we don't have generics, so we need to do line 21. That's kind of the downside of the standard. You need to do those lines, but it's not.
Yep.
It's not very, very inconvenient, really, and that's all there is to it.
Exactly. So right. Yeah. Yeah, and even though this looks a bit clunky, it's important to understand that now there's an actual standard around this metadata. And of course, in this example, because we're humans and we're just, we already know that it supports this type. Even before this, you could check if it supported this metadata views display type. We just know it does, and so we're accessing the collection this way. And so, we're getting the NFT, we're borrowing the view resolver, we do nft.resolve view, because that's what it lets us do. We pass in the type we want, and then it gives us back that view. And so we can take that view and get the name, description, thumbnail, and push that to our data struct. And then this rest of this is the same, and we return our NFT result here. So if we run this code, it should work just fine, and boom, it does. So if we look at all of our fields right now, it says Bjartek, a cool person, the thumbnail is the same. And the rest of it is also the same. So this is just the other way of getting the metadata stuff. Boom.
Yeah. And actually, what's really funny now, if you go into the example NFT and you copy the public path at the bottom, just copy out the value of the public path, right? You don't reference that. So
this one?
Yeah, the entire line. Yeah, that one. And you go back to the script again. So you see, the only reason you need to implement a concrete implementation here on line 2 is because of that public path. So if you just
on this line,
if you just go in there, you can delete the imports to example NFT.
Oh yeah, you're right.
Yeah, you don't need that. So you're totally generic. Like you're just browsing a generic thing, and there's a PR, another PR that what was the name? What was the I sent you that earlier. Yeah, it's Cadence 208.
Oh yeah.
That will allow you to have, you don't have to look it up now, we can send it later, but it will allow you to have a storage API where you can query for storage. And one of the things I want there is to be able to give me all capabilities that can be borrowed as a resolver collection. And if you can combine those two things, then suddenly you will be able to get all of your resolver collections and get all the ways to display them. And it won't be, nothing will be hard coded. Everything will be generic. You can discover data and you can play with data. And that's the end goal kind of here, to get to that state where you can discover and find out things and you don't need to hard code and know all the things, right?
Yeah, I mean, look at that, right? I mean, we don't even import example NFT, and like Bjartek was saying, you know, in the next when the was the cadence 2.08 you said comes out, we will be able to iterate over, you know, a bunch of paths and be able to get metadata without having to import you know, 1,000 lines of imports, you know, for all of our contracts. We're just viewing a generic thing here.
Yeah, so if you go to the find on flow on GitHub, you can, if you go to github.com/find on flow and find
and
find, and you go into scripts.
Yep.
And you go to collections.
The
top one.
Oh yeah, this one.
Collections. Yeah. Here you can see all the imports, right?
Yep.
All the imports for the different types. All of that will just go away. Go further down. I see further down. Here we have like almost the same struct as you have here. Here is how you do it for flowcharts, right? Because there's no standard. Here's, if you scroll further down, that's where the way we do it for verse.
Wow.
This is how we do it for goobers.
Wow.
This is rare rooms. This is MotoGP.
Yeah.
and Jam, and we just added evolution today.
Yeah.
And so a lot of this code can just go away. But you might ask, so what if I have an API that you need to resolve things with, because I have my metadata on IPFS, like they do in ERC 721 on Ethereum, for instance? Well, the point is, if you go back to the playground, Jacob, there will be a type that is that will support that scenario as well. So instead of implementing the display struct, you can implement another struct that basically says that in order to get the metadata for this NFT, you have to call this URL according to the ERC 721 or OpenSea, I guess, specification. Then you, of course, need to pre-process the results here off-chain before you can display them. But it's a lot better than the alternative, right? Because then at least you have a standard for that as well.
Yep. Exactly.
So this will not fit everybody, the display type and these structs, but because it will fit everybody that has metadata on chain. But not everybody have metadata on chain because it has been so hard up until now. But at least I hope that all future solutions on Flow will have the display type metadata on chain, so that we can create. I mean, as I said, I work on Find, and in Find you actually we show all your collections based on this. We're going to show all your collection based on this information that you can see here, right?
Yep.
So right now we're hard coding it, but we want to move to a generic way. But
yeah, honestly, I have nothing more to say because I feel like you just said that pretty well. I mean, the only thing I would like to add, you know, is that like we were saying earlier in the video, this is just one example of a display struct. If we wanted to, we can make a new contract with our own, you know, our own structs in here, and then just add that as a new view here, add the implementation, and then we could view it as such.
Yeah. So we also talked a lot about a royalty view that will enable you to specify royalties. For instance, for verses, we have multiple royalties. We have one for the minter and one for the artist, and then you can specify like a capability to a wallet or a cost or whatever you like, really.
Yeah.
But there will be a standard for royalties as well, because that's a very, very key part here. So that's coming. We're not sure on how it's going to be yet, but we had some meetings. Identity, yes. I really want identity here. I hope it's coming. And the reason I want identity is to expose the UUID field of all resources, because the NFT spec doesn't expose this field in the standard interface, right? But all resources on Flow have a UUID that is unique across all resources, right?
Yep.
So it's a unique identifier for all resources across the blockchain, right?
Yep.
I also want the identity to have the ID and to have the type and maybe even the address or the owner of things. We will just see what's going on, but I think it's really important. But it's really up to Dapper what they want to add. But if Dapper doesn't add it, somebody else can always do it, right?
Yep.
The community can also create views. So I imagine a future where we can kind of have a way of developing solutions where you see Jacob is already implementing it, right?
Yeah, it's exciting.
So we can have a solution where we can have a future where you have a solution that in order to use me, you have to implement these views.
Hmm.
So the contract between us is these views. That's the contract to use me. And when you use me, I will emit these events out back to you. That's the outgoing part of the contract. And when I'm saying contract now, I don't mean cadence contract. I mean more like the sign-by contract, if you're familiar with that pattern. But
Yep.
it's an old pattern from a really awesome old computer language called Eiffel. But anyways, I think that will can have a resurgence on Flow because it has all the building blocks to use that now, because you have input parameters, that is views or what you can be viewed as, and then you have transactions that are your behaviors, and then you have outcomes, that is your events.
Yep.
And while I was ranting, Jacob was doing actual work and implemented the identity, right?
Yeah, so I got too ahead of myself, and got really excited, so I wanted to implement the the UUID or the identity as well. So you'll see all I did was I added the identity here because we support it, added the implementation here. If we deploy it, then if we go to our script, I mean, we could very easily get the view here by accessing the identity. So
Yep.
I mean, I don't know if I want to. I guess we could do that really quickly, right? Why not? Equals NFT dot resolve view. We pass in the type, which is metadata dot identity or metadata views. Yep.
Identity.
Yep. Metadata views. So let me go ahead and fix that.
It's wrong. Yeah, views there. Yeah.
And then we would say, let display equals view as metadata views dot. Oh, I guess I should name it identity because that's what it's called, identity. And then if we wanted to, we could say data dot identity. Or data.uuid, we'll add that equals identity.uuid. Let's just go ahead and add that to our data here.
Awesome.
Like so, and then we can just add that right here. So self.uuid 0. And if we run this script, then I think I might have. Oh well, because I have to set up the account and all that again. So if we go back in here and set up the account, boom. Mint it into account 2. It's just I redeployed the contracts. That's the only reason.
Yeah.
Gotcha. And so then normally you wouldn't have to do this, and so then if I sign this from account 1,
yeah, like
GG.
Good game.
GG. Then if we go ahead and execute, you'll see that look, we can actually let me make sure you can see on the screen. Yeah, you can. So if we go scroll through here, I think it should be the last one, maybe.
Yay!
Right there, boom, UUID is right here. So I can let me even move the cameras around so you guys can see it. But boom, there's the UID in the bottom right. So you see how simple that was, just to add a new view, and now our NFT supports the identity thingamabobber.
Yeah.
So boom.
And so Pete at Dapper has also promised me that Dapper will set up a fast lane or a way to get your contracts approved for the standard a little bit faster than the normal flow. So when you adopt the standard, separate the code changes you have that are different from the standard to the other code you have, right? So only implement the standard in when you want to update the contract, and then there will be a fast lane so you can get your code deployed earlier, because everybody will benefit from you implementing these views, right?
Yep.
The only downside is really that it can require a bit of relink solution. So what I actually would propose, if you go to number 3, Jacob.
Oh, this one?
Yeah, is that if you go down to the public interface, yes, you actually add the borrow view resolver here. Because if you add the borrow view resolver here, then you don't have to relink everything, right?
Yeah.
Because if you don't, you have to relink the world basically and add a new classifier. But eventually, new solutions will not do that. New solutions would use the new method, right?
Yep.
But there are ways to getting around that. But
Yeah. Exactly.
unfortunately, you would need relinking, but it's not very hard to relink either when people do a transaction and
Yeah, that's not too
gracefully
bad.
just transfer them over.
Yeah. All right. So that's, I mean, that's all I have to say about it. Are you fine wrapping it up there, Bjartek?
Yeah, I'm done.
All right. So
Sorry for ranting.
no, not at all. I mean, this was awesome. I think we really went through a lot. And I hope that this video is helpful for all of you that want to get, that wanted to get introduced to the metadata standard. And I can assure you that within the upcoming month or two, we will all be using this to a great extent. So it's important to get familiar with it now.
Yeah, I really hope so.
Yep.
The future is looking really bright.
I like that.
If we can get this and the default implementations and the storage manager merged, it will be a lot. You don't have to write a lot of code to generate to create an NFT anymore.
Yep.
And it will be just a lot more standardized and a lot better.
Exactly. All right. So that's it for this video. Bye, everybody. Thank you, Bjartek, for coming in and doing this with me. And I'll see you all in the next one. Bye.
Bye.